Hey there, folks. Welcome to the slideshow video about time of death calculations. And so we're going to work with clues based on what happens when a human being dies. Okay, now you should already have a PDF of this handout, or maybe you printed this handout. It includes a lot of the things that are in this slideshow, but there are some details in this slideshow that are not in the handout, so you're going to want to watch and listen along with me. But this resource, this note sheet, is something you could have while you're getting ready for the required assessment, that eDoctrina quiz. All right, a little historical stuff about death. Way back in the 17th century and prior to that, if you had a really weak heartbeat or you were in a coma, it was practically the same as being dead. People thought you might be dead. It was hard to tell. Is this person still alive, or are they just barely alive? And so there was a lot of fear back then of accidental burial, and rich folks could even afford coffins that had a little gadget with like a string and a bell, and in case they actually woke up after they had been buried, they could ring the bell. Now, you might have heard this story, and you might have heard someone say, oh, that's where the term saved by the bell comes from, but actually that's not true. The term saved by the bell comes from the world of boxing, okay? The bell that ends a round in boxing. Anyway, fast forward to today and death. If someone dies today, we are pretty certain that someone is dead or not dead due to modern medical advances in technology. And if someone dies and a crime has been committed, there's probably going to be an autopsy. An autopsy is an examination of the deceased by a pathologist. A pathologist is a medical doctor whose specialty is disease and the underlying causes and mechanisms of death. Okay? So the goal of the autopsy is to determine these three things: the manner of death, the cause of death, and the mechanism of death. And these are three special words in forensics that you might think, aren't those kind of all the same thing? They have special different meanings. Okay, manner of death, how someone dies. There are only four choices for manner of death: natural death, accidental death, suicidal death, and homicide. Okay? Natural death is the most common. Accidental death, an accident. Suicide and homicide is by an intentional act of another person. Okay? Now, the manner of death can be a little tricky to determine. This is why we have detectives and forensic science in from some perspectives. Okay? So how would we categorize the manner of death in these examples? So remember, there are only four choices: natural, accidental, homicide, and suicide. A man with a heart condition is attacked and dies from a heart attack during the assault. Technically, that's going to be homicide because it was due to the purposeful actions of another person. An elderly woman dies after being kept from receiving proper health care by her son. Again, it's the actions of another person that led to this death, so that would also be homicide as the manner of death. All right, cause of death is a little bit different. It's the underlying reason that someone dies, okay? Was it a disease? Was it physical injury? Was it a stroke? Was it a heart attack? Or, in terms of a homicide, bludgeoning, shooting, burning, drowning, strangulation, hanging, suffocation, all the different ways that a human being can be brought to their death. Now, the term proximate cause of death is really kind of nerdy. This won't be on the test, but it's the real underlying cause of death, but not the final cause. So, for example, if you're exposed to large amounts of radiation and then you get cancer, the proximate cause of death is the radiation. It's a natural manner of death. The final cause of death is cancer, but the proximate cause is radiation. Or if you have high cholesterol and you die of a stroke, the proximate cause of death is the high cholesterol. It's a natural death, but the cause of death is the stroke. Again, getting very nerdy, not on the exam. Okay, mechanism of death is what actually happened in the body to cause you to die, the specific change in the body that brought about the cessation or ending of life. If the cause of death is a shooting, the mechanism of death might be partial loss of blood, or exsanguination, which means basically total loss of blood, or it might be that the bullet hit you in the brain and it caused your brain functions to stop. Okay? If the cause of death is a heart attack, the mechanism of death is the heart stopping to beat, or that's referred to as pulmonary arrest. All right, time of death is something that is going to be determined by the pathologist, okay? And they're going to use their medical knowledge, but also some specific forensic knowledge. They're going to use these ideas of Algor Mortis, Rigor Mortis, and Rigor Mortis to determine time of death. These are three Latin phrases that we're going to go through next, okay? Now, these can be accurate within 24 hours of death, but after 24 hours, the pathologists have to use other methods. But we're going to focus on Algor Mortis, Rigor Mortis, and Rigor Mortis. Okay, Algor Mortis is the cooling rate of the body. Okay, basically, you take the temperature of the body in the mouth, in the armpit, maybe rectally. Sometimes you actually cut open the body and take the temperature in the liver. That would be a little more accurate. Then you use a mathematical formula, and I'll show you how to do that. The formula is good for the first 36 hours. It's actually most accurate for the first 12 hours. And eventually the body is going to cool off until it hits the same temperature as the environment. Let me just show you what that looks like. Okay, when you're alive, you are at 37 degrees and you stay at 37 degrees. Then if you die, okay, you're eventually going to get to the same temperature as the room or the environment that you're in. Okay, room temperature is about 21 to 24 degrees. If your body is outside, it may get down to a lower temperature eventually. But at first, your body cools down at a certain rate of 0.78 degrees per hour. Okay, after 12 hours, the cooling slows. You cool off more slowly, and eventually your body will reach the temperature of your surroundings. But someone might find the body right here, and then that temperature can help you backtrack to possible time of death. Or maybe you find the body at this time. You can backtrack and figure out the possible time of death, and I'll show you how to do that. Algor Mortis, again, is the cooling of death. This cooling rate, it can be changed by a bunch of different factors. The air temperature can change it, whether it's warm or cool outside. The amount of clothing on the individual can change it. Is the clothing wet or dry? Is there a lot of air movement, or is it in a room where there are a whole bunch of fans or an air conditioner? What are the weather conditions outside, sunny, cloudy, etc.? Was the body found in water, totally underwater? And then babies and small adults, they cool off faster due to a different body mass ratio. So there's different calculations for that. You don't really have to worry about it. We'll be worrying about basically standard size adult bodies. All right, Rigor Mortis. Okay, this is the second of these three things to help us calculate time of death. Rigor Mortis means the pooling of blood inside the body after the heart stops. Basically, gravity pulls the blood to the lowest points in your body. This is also called lividity, Rigor Mortis or lividity. Basically, here's what happens. Your heart stops, your body starts to decompose, the blood starts seeping down through your tissues inside your body, the blood settles into the lowest parts of your body. Now, this depends on your body position, whatever part of you is lowest to the ground, and the red blood cells break down, blood kind of leaks out into the body cavities, and so you get something that looks like this. You get a change in color that's visible through the skin on the lowest parts of the body. Okay? And here's a slightly gross picture of what lividity actually looks like. Okay? It's a purplish red discoloration. It can help you indicate time of death. It's only on a portion of the body that is lowest and closest to the ground. It starts happening within 2 hours, and it becomes permanent after 8 hours. So this can actually be quite useful if you think about it cleverly. Now, yes, air temperature will change the time it takes for lividity to set in. Basically, if the temperature is really warm, this will happen faster. It'll start sooner than 2 hours. If it's a cool temperature, it will happen slower. It'll start later than 2 hours. Okay. And we'll go through some examples with this. All right, Rigor Mortis tells you the position of the body basically during the first 8 hours after death, because after 8 hours, it is permanent and it doesn't change. So if the corpse is lying on its back and was lying on its back for those first 8 hours, the lividity will be along the back and the backs of the legs. If the corpse is lying on its stomach, the lividity will be on its belly and face and the front of the legs. Now, where your body is pressing against the ground, there will be no lividity because that pressure kind of squeezes the tissues and the blood can't really pool there. That's not something you have to worry about too much. Lividity can also show you if the corpse has been moved between the 2-hour mark and the 8-hour mark. You can have dual lividity, like two different patterns. Basically, one pattern could be from how the corpse was lying in the first 2 hours, and another pattern is from a later position, like between 2 hours and 8 hours if the corpse was moved. You get two different patterns. Now, if we had a corpse like this where they seem to be lying on their belly, but the lividity is all in the back, well, that must mean that for the first 8 hours, they were lying on their back. After 8 hours and the lividity had become permanent, then they were flipped over, and sometime after that, someone found the corpse. Might be a way to interpret that situation. Again, dual lividity means, okay, sometime in the first couple hours, you got a partial lividity, in this case, say on the back, along the back, then the body was flipped, we got partial lividity on the front, and then maybe it was flipped again to some final position. So you get two different lividity patterns. You've probably heard of rigor mortis, the idea that a corpse, the arms, legs, muscles of a corpse become very stiff after death. So it's rigidity of the skeletal muscles after death. It starts within 2 hours of death, but it disappears completely within 36 hours. And the corpse will be at maximum rigidity after 12 hours, sort of between the 12 and 15-hour mark. And with rigor mortis, that stiffness starts in the head and the neck first, okay? Then it works its way down the torso, down all the way to the legs. So if you have a corpse that is rigid in the face and neck only, but not the rest of the body, well, that means the rigor mortis just started. The time of death was just over 2 hours ago. Okay? If you have a corpse that is rigid in the body, but not in the face, that means the rigor is starting to fade. That means we're past the maximum rigor mark of 12 to 15 hours. It's been over 15 hours since the time of death because the rigor has faded away from the face, but not from the rest of the body. We'll do some more examples of this and it'll make more sense. That I'm sure right now this sounds very confusing. Hit pause and read a little bit about the underlying cellular cause of rigor mortis. There are a whole bunch of different factors, warming factors and cooling or insulation factors that can affect rigor mortis. We'll talk more about this in another video. Okay, I just want to point out something. In your reference tables, you've got a little section about stomach contents and stages of decay. And these are pretty simple to use, but I just want to show you one or two things. When you're looking at stomach contents to make a prediction about time of death, we have these facts. Basically, your digestive system stops when you die. So the stomach and digestive system contents can tell you how long before death the victim ate their last meal. And what we do know is that your food goes down your esophagus to your stomach. Okay, so from 0 to 2 hours, your food is in your stomach starting to be digested. Okay, so and then after about 4 to 6 hours, the food moves on to the small intestine. After 12 hours, it leaves the small intestine, goes to the large intestine, and then finally, after about 24 hours, your food is generally released by the body. Now, everyone's body is a little different, but these are general patterns that we see. So, for example, if you look at the second half of this page, okay, if we find a body with undigested food in the stomach, well, the time of death was probably 0 to 2 hours ago. Okay, that person has been dead for less than 2 hours. There's still food in the stomach. If we find a body where the small intestine is empty, but the large intestine contains some waste, well, it's probably over 12 hours because that's how long it takes the food to get to the large intestine. But it hasn't been 24 hours yet because the large intestine still contains waste. The body hasn't emptied it out in the normal human fashion yet. Okay, these stages of decay information, you can read through that in your reference tables, and I'm going to put up a slide. Here's a little bit more information. Hit pause if you want to read through this, and hit pause if you want to read through this. And some other factors for time of death. The eyes can give you some hints, and the presence of insects on the body. You may have heard about this in various forensics TV shows and documentaries. That's something that we're not going to really get into this year, but you will see a chart in your reference tables about using insect clues for time of death. That will not be on any quiz or exam this semester. All right, thank you for watching.